This is a video for AP Statistics Chapter 9, and in this video we're going to discuss sampling distributions, and this is the first part of Chapter 9. So to start things off, let's just do some basic vocabulary. So a parameter is a number that describes the population, and it's usually unknown. And a statistic is a number that can be computed from the sample data, and usually we will use a statistic to better estimate the parameter and kind of, get a feel for what the actual population looks like. And then a sampling distribution is a distribution of values taken by the statistic in all possible samples of the sample size from the same population. So this is just, remember that parameter kind of sounds like population, parameter, population, statistic. We know that that's just a number that can be computed from sample data. So sample, statistic. Both start with the same letter. And so what we'll use when we're doing a sampling population of P is we'll call it P hat. And that basically means that when you ever have P hat, we're doing, proportions. So P hat equals the sample proportion, and this is basically the number applicable over the total population. So if we're trying to figure out the proportion of people who buy Crest toothpaste, then we'll do the number of people who buy that over the total population. And then our mean is just P. So ideally the mean is going to be the exact number in the population, but usually it's just an estimate. And then to calculate the standard deviation, it's going to be P times 1 minus P all over N, and then you take the square root of that. And then also something to discuss is bias and variability. So there's kind of different types of things. There's something called accuracy. Accuracy, I think that's how you spell it. And then precision. So here we have a pretty, we don't have a lot of accuracy. This is kind of an example from the book that displays you in dartboard form. So right here we have all these, data points around the bullseye. So in this situation we want the bullseye, which is, right in the middle there, here. And so this data set, it's not very precise because, it flows all around. It's not in one area, and then it's also not very accurate because we don't even have any pieces right there in the bullseye. So that's an example of low accuracy and low precision. And then here, we do have, accuracy that some of the data points are in the bullseye, but it's not very precise. We have a whole different pool around that bullseye. So this would be, accurate but low precision. Here, this would be high precision but low accuracy because we have a lot of group data grouped together, clumped in a cluster. So high precision, but none of it's near the bullseye, so it's low accuracy. But then if we move it here, we have high accuracy because it's all in the bullseye, and then also high precision. So this would be an ideal kind of data set with low bias and low variability. And then there's also two things that we have to keep in mind with sample proportions, and it's two kind of guidelines. First is actually called rule of thumb 1, then we have rule of thumb 2. And rule of thumb 1 says that you can only really use the sample proportions if, in this case, N is like number in the sample, like subjects or people. So if in the sample 10 times the number of subjects, if that's less or than or equal to the total population, we can use it. And then rule of thumb 2 says that if the number of people times the P, kind of like the percentage kind of the population that use it, is that must be greater than or equal to 10. And same must be said for 1 minus the percentage of population must be greater than or equal to 10. It's just like 2 rules. Remember which one's rule number 1, rule number 2. Just kind of keep them in mind when you're performing all these things. It's great to write it out to show the conditions and show your teacher and the AP graders that you know what you're doing. So yeah, this is sample proportions video 1.